Let us now move to our next problem, which again is a case of biquadratic equation. Let me zoom in and let's read it carefully. So we need to solve this equation. Degree is 4. That means as many as 4 roots are going to be there. Given that the sum of the two roots is equal to the sum of the other two. So from here, you can frame an equation. Okay. Let us write down the entire biquadratic equation. As it has 4 roots, let me write them as alpha, beta, gamma, and delta. So we've been given this relationship. Sum of the two roots is equal to sum of the other two. Let's say that the two roots are alpha plus beta, then the sum of the other two is going to be gamma plus delta. Let's write it down. Let's start now. So our usual approach is to start with the second term, negative, positive, negative, and positive. And now let us start with the sum of the roots. Alpha plus beta plus gamma plus delta is going to be equal to negative of negative 8 divided by the coefficient of x to the power 4. Here it is. Okay. Again, if you watch carefully, these two are equal to each other. So you can replace or substitute gamma plus delta by alpha plus beta. So here over to the LHS, it is going to be twice of alpha plus beta. And this is going to be equal to plus 8. Hence, alpha plus beta is equal to plus 4. A very important relationship. And by the way, since these two are equal, if alpha plus beta is plus 4, gamma plus delta is also going to be equal to plus 4. Now, how can we move forward from here? Let us go with sum of the product of roots. Okay. But sir, what kind? 2 at a time. Sum of the product of the roots, that means alpha, beta, beta, gamma, and gamma, delta. Okay. And this is going to be equal to plus of plus 21 divided by this 1. Done. What else can you do over here? Sir, if we take beta as common, we will get alpha plus beta. Gamma, and then if we can take delta as common, inside the bracket will be gamma plus alpha. I mean, I cannot come to any sort of conclusion as such. Okay, so let us leave it over here. Let us move to the sum of the product of the roots, a combo of 3. Okay, like this: alpha, beta, gamma, delta, and so on. Now if you watch, negative of negative 20, that is positive 20. And we can make a combination over here. Just watch out for these terms. If you take alpha, beta is gamma, inside the bracket you are going to have gamma plus delta. And here if you have gamma, delta is common, inside the bracket you will have alpha plus beta. Okay, so this can prove to be very handy. And let me just write this down. We also know from the previous equations that gamma plus delta or alpha plus beta, both of them are equal to 4. So 4 can be taken as common and it will cut this 20 by 5. So we have this new relationship: alpha beta plus gamma delta is equal to 5. This is going to come in very, very handy. Please watch this carefully and write till the end. Okay, here we go. The next thing we'll do is, how many relationships? Sir, it is a biquadratic. That means 4 roots, 4 relationships. 1, 2, 3. Again, the 4 relationship is alpha, beta, gamma, delta. Product of all of them is going to be equal to plus of plus 5 divided by 1 again. Here it is. Let me write it this way: alpha, beta, gamma, delta is equal to 5. Okay, so far so good. Let me write these two again. Okay, let us draw some conclusions. If you watch, this can be assumed as R1. This can be assumed as R2. That's R1, that's R1, that's R2, that's R2. Don't you see a pattern over here? Something is clicking inside your brain. Sir, this looks like sum of 2 roots is equal to 5. And this looks like product of the same 2 roots is equal to 5 again. So we can say that x square minus sum of the roots into x plus product of the roots is equal to 0. We can say that. Okay. So alpha dot beta is in itself a root. That's what we can say. And based on this, so this is going to be x square minus 5x plus product of the root, that is 5 again. Here it is. And now you can use simple the formula approach. You can go for that, and you can simplify this. 25 minus 20 will be root 5. So the result is 5 plus minus root 5 by 2. Okay, 5 plus minus root 5 over 2. That's the result we have. This, by the way, is a root. What kind of a root? Root R1. And we know that root R1 is nothing but alpha beta. This also is nothing but a root. R2, and that's gamma delta. Done. So let me move to the next page. Remember, this is alpha beta and this is gamma delta. Alpha beta, this is gamma delta. Done. So we already know that alpha plus beta is equal to 4, and at the same time gamma plus delta is equal to 4. We know these things. How can we proceed from here? Again, you can assume this to be your root 1 now, and this to be your root 2 now. This is your root 1, this is your root 2. In the same manner, you can go for x square minus sum of the roots, that is 4x, plus product of the roots, that is 5 plus root 5 over 2. You have another quadratic equation. Again, you can apply the formula and calculate the value of x. This is how it goes. Again, you have to simplify this. I've already done the simplification. This is what you get eventually. I thought, why not check the answer at the back of the book? So I checked. This basically is a problem from exercise 1 BS Grewal, Higher Engineering Mathematics. So I checked the answer. It was incorrect. My answer was different. So I thought, why not plug in this value inside a calculator and get the value in decimals? So I did that. And I did the same for the answer which was written in the book. It was also an answer in roots. So on comparing both the decimal values, they were absolutely same. Why am I getting a different answer over here? So this needs actually further simplification. Students, if you watch, this basically can be split up into 5 plus 1 minus 2 root 5 times of 1. If you watch carefully, this basically is nothing but root 5 and its square plus 1 and its square minus 2 into root 5 into 1. This also can be written as root 5 minus 1 and its whole square. So inside this, you can replace this essentially by root 5 minus 1 and its square. Let us do that. Out of the root, it becomes this. Follow a positive value. 4 minus 1 will be 3 plus root 5 by 2. Follow a negative value. 4 minus of minus 1 plus 1. 4 plus 1 is 5. 5 plus root 5. 5 minus root 5 by 2. So this is going to be your another answer. Okay. In the same fashion, you can apply it for these two, gamma delta and gamma plus delta. X square minus 4x plus this quantity. Okay. Apply the formula. Simplify it. 6 plus root 5. So here we had root 5 minus 1. Here you are going to have root 5 plus 1 and its square. Square inside the root, remove the root. That's what you get. Take the positive sign, you are going to get the result as 5 plus root 5 over 2. Take the negative sign, the result is going to be 3 minus root 5 over 2, and that's the final answer. These are the 4 roots which we were supposed to be calculating. Okay. In less than 8 minutes, we have solved the entire problem. This was a bit long. I've followed a slightly unconventional approach, but it is indeed really very, very effective. I'm sure this content has helped you understand the nuances of solving biquadratic equations. If you find this content helpful, do like and share the video with your friends, with your classmates, and also subscribe to the channel and press the bell icon for all the future notifications. Thank you very much. This is Manas Patnaik signing off. Take care. Have a nice day.